Hello and welcome back. Today we're looking at session 5. We'll be looking at operators. In the previous session, we looked at the decision-making constructs and we saw how your program makes decisions. So today we want to look at the various operators that are used in your program. Let's start by looking at the objectives. Now, by the end of this session, you'll be in a position to define what is an operator. You'll be in a position to list the different types of operators, to describe the use of arithmetic operators, describe the use of relational operators to make comparison. You'll also be in a position to explain the process of associating selections with logical operators. And finally, you'll also learn how to, you learn the precedence of operators in an expression. Let's get started. Introduction. Now, computer operations can be arithmetic such as addition, division, or even comparison, where one variable is compared to another variable. And these kind of operations are performed using operators. Operators. Now, an operator is a set of symbols that help to manipulate or perform some sort of function on data. And we basically have three types of operators, and their names are given below. We have the arithmetic operators, the relational operators, and the logical operators. Let's look at each of these. We'll start with the arithmetic operators. Now, using arithmetic operators help us to manipulate numeric data, and they help us to perform common arithmetic operation on the data. We can see the various symbols given there. We have the plus for addition, minus to subtract. We have the division or the forward slash. That is what we use to divide. And we have the asterisks. That is what we use to multiply. We have a detailed table that shows how these symbols are used. Let's look at it. Now, the table shows a list of arithmetic operators common to most programming languages. The table breaks this into the operator, its description. We have an example, the result, and the equivalent in C, and those programming languages based on the C programming language, which we'll be looking at in subsequent semesters. Let's go through this quickly. We have the plus, addition, example 9 plus 2, the result is obviously 11. The C equivalent is the plus. We have minus, it's used for subtraction. Example, 9 minus 2 gives us 7. The C equivalent is still the minus. We have the forward slash, which is used for division. And we have an example, 9 divided by 2 gives us 4.5, and the C equivalent is given there. Now, something I would like to mention here is that when working with programs, we have two types of division. We have integer division. So for this, you can get two results. If you're dividing 9 divided by 2, the way we would normally do it, you'd actually get the same result, okay? You'd actually get 4.5. Now, when you're doing integer division and you do 9 divided by 2, this one gives you 4. What happens with the other part is that it is dropped, what we call truncating, okay? So kindly note that. So here we are doing what is called floating point division. We move on. We have multiplication. The asterisk is what is used for multiplication. An example is 9 times 2, which gives us 18. The C equivalent is the asterisk symbol. We have the caret. The caret is used for exponentiation. Exponentiation means raising one number to a given power, like this example we're given here. We're given 9 raised to power 2, which results in 81, and the C equivalent is the caret symbol. We have modulus, MOD. In other books or slides, you'll actually see this being referred to as modulo. We have the example given here, 9 mod 2. The result is 1, and the C equivalent is given here as the percentage symbol. Let's look at a practical example. Now, I've already done the division here. We have 9 divided by 2. 2 goes into 9 4 times. We do the subtraction here. We get 1, and this is the one we are interested in. This is what we are calling the remainder. This is what we're interested in, the 1, and we drop off this other part. Okay, let's move on. We have the hyphen or the minus symbol, and it's used for negation. Example is -9. This is like when you want to convert a number from a positive value to a negative value. Example, you could have negative temperatures. The result basically is a negative number, and the C equivalent is the minus symbol. We move on. The negation operator requires only a single operand. Operand is the data which is being manipulated. Like in these previous examples, 9 and 2 are the operands for all these examples which we've used here, while the plus, minus, divide, times, the caret are the operators. Therefore, we are saying the negation operator requires only a single operand, and it's also known as the unary operator. All other operators require 2 operands, and they are known as binary operators. Precedence between arithmetic operators. The table shows the order in which each arithmetic operator precedes over the arithmetic operators. Precedence means like if you have multiple operators, what is going to be evaluated first in an expression? We start with the plus plus, that is the increment operator. It actually increments a value by 1. We have the minus minus, and this one decrements or reduces the value by 1. We have the multiplicative. The multiplicative include the times, the division, and the modulus. And lastly, we have the additive. Additive has the plus and the minus. Using the relational operators. Relational operators are used to compare 2 or more values or expressions, and it always evaluates or returns a value of true or false. And the relational operators are binary operators, and some of them are given here. We have the greater than, the equal, greater than or equal to, and the less than or equal to. The table shows the list of relational operators common to most programming languages. We have the operator, less than, description, this is less than. Example, 2 less than 9 evaluates to true. The C equivalent is still the less than symbol. We have the less than or equal to, and description is less than or equal to. This example is given here. 2 less than 9 evaluates to true. The C equivalent is less than or equal to. Greater than, this is 2 greater than 9 evaluates to false because actually 2 is less than 9. And the C equivalent is given here. Greater than or equal to, and 2 greater than or equal to 9 is false or evaluates to false. The C equivalent is given, equals, equal to, and this is what we have 2 equal to 9 evaluates to false. Now, one thing I would like you to note is that when you're dealing with C-based programming languages, we use the double equals to denote equivalence. This one on its own is used for assignment, so kindly note that. Then we have the less than and greater than. This means the not equal to. Example, 2 not equal to 9 evaluates to true, and the C equivalent is this. We also have the exclamation mark, okay? It also does the same thing. Now, precedence between the relational operators. There is no precedence among the relational operators. Therefore, they're always evaluated from the left moving towards the right. Using logical operators. What exactly is a logical operator? Now, a logical operator is used in situations where multiple conditions needs to be satisfied. For example, we want to combine the results of several comparisons as required to present a single answer. And they usually return the results in either true or false. Like let's say somebody is going to be awarded a certain privilege if they're older than 18 and they come from New York City. We can see we're using the AND operator to combine these 2 conditions, okay? Now the table shows the list of logical operators. We have the and it results to true only when both conditions are true. The C equivalent is the double ampersand. We have the or. The result is true when either of the two conditions is true. We have the pipe symbol, and we have the not, operates on a single value and converts true to false and false to true. And we have the exclamation mark, which is called the bang symbol in programming. Okay, let's look at the truth tables of this before we move on. Now, we can see the definition of what a truth table is, and the definition was obtained courtesy of Techopedia. According to what we have seen in your slides here, we can see that for AND, the result is true only when both conditions are true. And for the OR, the result is true when either of the two conditions is true. Not, basically, we've seen, negates everything. True becomes false, false becomes true. Let's go back and fill in these values very quickly. True and true, this is the AND, okay? We start with the true. So this is the only time that it will evaluate to true. Everything else evaluates to false. This will evaluate to false. The same here, and the same here. Now, for the OR, basically, we've said when any is true. So when both of them are true, it will evaluate to true. If we have true and false, this evaluates to true as well. When it is true and false, this also evaluates to true. The only time this evaluates to false is when both of them are false. And that is the result of this. Now, it's very, very important for you to understand this, especially when you will be dealing with the if or when we're using loops, okay? Because they have to evaluate to a Boolean condition. And the loop is going to stop when the loop evaluates to true or false. Let's move on. Precedence between logical operators. The table shows the precedence order for the logical operators. We have not has the highest precedence, followed by the and finally the or. Then precedence of operators in an expression. So the table shows the precedence among the different types of operators. We always start by evaluating the arithmetic operators. Then after that, we evaluate the relational operators and finally the logical operators. The parentheses, sometimes for certain formulas, the programmer may need to override the precedence rules. These rules can be overridden with the help of parentheses. We have an example here. We have this is 10% times basic salary plus house rate allowance minus the tax. Now, what we want to do here, remember we said multiplication and division have a higher precedence than addition and subtraction. Therefore, to override these rules, we are putting the operations in brackets. And basically, these are called parentheses in American English. We call them brackets, okay? So the innermost brackets will always be evaluated first, then you evaluate the outer brackets, then now you can do the other calculations. And with that, we've come to the end of the session. Let's look at what we have learned today. Operators are a set of symbols that help to manipulate or perform some sort of function on data. Operators can be classified into three types, namely arithmetic, relational, and logical operators. Arithmetic operators help to manipulate numeric data and perform common arithmetic operations on the data. Relational operators compare two or more values or expressions and always return either true or false. Logical operators are used in situations where multiple conditions need to be satisfied. In an equation involving all three types of operators, arithmetic operators are evaluated first, followed by relational operators, and finally logical operators. The programmer can specify the part of the equation that needs to be solved first using parentheses. That is it for today. Have yourselves a nice time. God bless and bye.